Alright, so hello, Miss Arum. My name is Muhammad Rizkiriawan and I'm from Advisory F and I'm in 11th grade. Currently and about to finish, hopefully, your physics class, which is Physics 1, which I'm taking in my second year of high school. Apologies. A brief explanation of reflection is the law of reflection states that it is when the bouncing back of a wave when it encounters a boundary between two different media. For example, a mirror, and you're pointing something to it, some sort of light to it. The angle in which the light is pointing to the mirror will reflect accordingly and exactly to the opposite side of the angle that is being reflected to the mirror. So if an angle is like this, then it will do it like this as well, but oppositely and exactly. For example, the reflection of a light on a mirror. Sun reflects off a wall, and water waves reflects on a beach. And it states that it is when the angle of incidence is equal to the angle of reflection, such as when I point a laser into a mirror, the point of incident equals the angle of reflection. And I have a real life example now. There's Mount Fuji, and there's a pond below Mount Fuji. Well, the pond will reflect the body of Mount Fuji. Why? Because of the light. So, let's say we looked at a pond, and this is the mountain. Well, we can see the reflection of a mountain on the pond. And to show you a better example, to give you a better picture, a reflection of a mountain happens because of the light. And this would be the real life example and why we can see reflection in our day to day aspect. Because again, light bounces off of the body, which is the pond. So interference is the interaction of two or more waves that combine to form a new wave pattern. A real life example would be throwing a pebble into a pond, two pebbles into a pond at the same time. Well, what happened is, which I'm going to show you in the demonstration really quickly. And now, but when we do it both at the same time, the ripples will eventually connect, which results in either constructive interference or weaker destructive interference. So stronger is constructive interference, weaker is destructive interference, depending on how the waves are aligned. It can increase or disrupt the waves. So from my eyes, I can see that within both pebbles, for example, they hit each other, the ripples becomes bigger because when it connects, ripples like suddenly go everywhere, and it's a sign that the ripples from each pebble will interfere with each other, and the pens act as pebbles, which I can see within my own vision. And my apologies for the camera, which can't see the ripples that well. But this would be what will happen in actuality. So when two pebbles are thrown at the same time, what you will see is when the ripple connects to each other, it creates a constructive wave interference. Which reflection is simple. We can just see from a mirror that reflects our own body, face, and everything because of the light. The light reflects off of the mirror. That's for reflection. Telescopes also uses reflection, and searchlights also uses reflection. Even cameras uses reflection. Many technologies in our age uses reflection as one of the main tool so that the technology could function. For for interference, my apologies, it's kind of different. So, interference is the merging between two waves, and it can help, or it did help, to found acoustics, optics, and even quantum physics, as well as now the more popular one that we use in our day-to-day life. We don't use pen and paper anymore like we used to do in the 1900s. Wireless communication. We did not have wireless communications, hence, by discovering, and the physicists back then, which I greatly applaud them, because now I don't have to write on a pen and paper and then send it and then wait 1 hour, or like not even 1 hour, more than that, a day or two, to be given back the letter I write to someone. Now I just have this, and this uses wireless communication. That is because the physicist has gained a good understanding and many discoveries through interference. For reflection, it has greatly helped our understanding of space. Why? Because of telescopes. Hubble telescopes that you have in your room, the big one, binoculars, everything related to those types of optics relates to reflection. And because reflection has helped, for example, the Hubble telescope in seeing the far depths of the universe and our space, we can gain a better understanding of space. Hence, why interference helped with our day-to-day communication, and reflection helped with our understanding of space through vision, just through vision and through the telescopes. And I believe that's it for my video. Hopefully this would suffice